Yeah. Hello, everyone. This is TFM Open Technical Forum. My name is Anton Komlev. I'm a tech lead of the same project in ARM. And on behalf of Trusted Firmware, I'm hosting this forum. Yeah. Today we have two topics in our agenda. So we replaced one topic, which Thomas kindly agreed to wait for 2 weeks and present it later on the next technical forum, because we want to show you what is going on with the build system update. We are looking for quite some time. Okay, let's go through the agenda. First one is ongoing MCU boot alignment update, what David Winzer planned to present. David, are you ready?
Yes, I'm here. I'm sharing my screen in a second. Please let me know if you can see the presentation.
Yeah, I do.
Yeah, we can see.
Okay, perfect. And do you see that little zoom window in the upper right corner?
No,
or is
just,
it just for me? Okay.
just the presentation.
Okay, perfect. So, hi everyone. My name is David Winzer. Today, I would like to give you a really brief update on the MCU boot alignment work, which has been happening in the recent months. But why is this needed in the first place? As you may already know, the TFM uses its own copy of MCU boot as its secure bootloader, and naturally, from the time the fork was created, it started to increasingly diverge from the original code base. There were several code synchronizations between them, and some of the new features that were introduced in TFM have been upstreamed to the original repository as well, but many of them not. It all takes a lot of extra time, which may not worth it anymore. And because of this and for other reasons, TFM will use the upstream MCU boot as its default bootloader in the future. As a first step, from January, TFM began supporting the use of the original MCU boot, which has a few clear advantages. For example, it is being used by more projects, and this way the contributions are not spread across multiple copies, and the MCU boot has a relatively extensive simulator environment which can make it easier to test new features in the bootloader and regression as well. About the status of the transition, the TFM 1.0 was released in March, which already supported the 1.4 version of MCU boot. However, for a complete transition to the original MCU boot, we had to upstream all the necessary features which were only available in TFM's fork, and also update TFM's build system accordingly. There will be a bigger change with the release of TFM version 1.1, as it will use the 1.6 version of MCU boot from this time as the default bootloader. The 1.6 already includes the support of boot data sharing for the initial attestation service and usage of hardware keys and rollback protection to meet other requirements of the PSA trusted boot and firmware upgrade specification. And what is left out of this and will be part of a newer, ideally the following MCU boot release, are the no swap and the RAM loading upgrade strategies. A pull request to support no swap has already been opened on GitHub, and it is in good shape. Basically, it is an upgrade strategy without the need to copy the images from the secondary to the primary image slot, making the code much simpler and its footprint smaller. In this mode, the bootloader simply selects the latest valid image based on the image version numbers and runs it directly from its flash partition. And after this PR is accepted, the RAM loading will be pushed to GitHub as well, since from the source code's perspective, it is just an addition to the NoSwap. And as soon as these are all also upstreamed, in theory, it becomes possible to remove the fork from the TFM repository. A few words about the differences and changes that I think are important and can help avoid misunderstandings. The first one is that the definition of the TIBLN field in the header of the shared data entries has changed. In TFM, this field includes the size of the data entry plus the size of the header structure, but in upstream MCU boot, it only includes the size of the data. But this is going to be handled in TFM and will be transparent ideally for everyone, but I felt it was important to highlight this. The second one, NoSwap, has been renamed to direct execute in place. Basically, it was just pushed to GitHub under a different name. And another important change is that TFM will use the image tool script as a package instead of using it from the MCU boot source. It might be important from that point of view that the list of its parameters is slightly different compared to what is currently used in TFM, and it will also need to be installed along with other Python packages as a new requirement. A few words about the future activities without claiming completeness. Another advantage of using the original MCU boot is the instant availability of additional features like encrypted image support, image update over serial port, and so on. Supporting the multi-image scenario with a direct execute in place mode could also be one of the tasks for the future. And also, the last item is the complete removal of the MCU boot fork, which I've already mentioned, as soon as it's established that it is no longer required to retain it. And for this item, I would have a question. Is there anyone in this meeting whose devices are already on the field with the TFM's MCU boot fork? Because the previously mentioned TIBLN field deviation can cause a problem here. Just shout if you have any comments on this. Otherwise, that would be the end of my update. Thank you.
It'll be a good idea to send a mail as well on the mailing list.
Yes, of course.
Yeah.
Yeah, thank you, David.
Hey, excuse me, it's Michael Thomas. I have a quick question, David.
Sure.
The 1.0 release, and when is the planned date for 1.1?
I think this is a good question to Shebo, and we have Shebo on the call. Maybe something wrong with Shebo.
Yeah, you're muted, Shebo.
It's planned in somewhere in the middle, in the first half of July, the 1.1. So the exact date is not defined yet, but we plan to do it somewhere first half of July.
Okay.
Thank you, Anton.
And okay, on your slides, you mentioned on those three phases, you have 1.0, 1.1, and 1.x. It says available bootloaders, TFM fork, and MCU boot. What do you mean by that? Are you trying to say that we can use either MCU boot or TFM's fork equally with TFM?
Yes, from January there is a CMake option, which is called, oh, sorry, it is my mouse. So this MCU boot _ repo option, with this you can switch to the upstream MCU boot instead of using the fork in TFM. But of course, as I mentioned, here it has its limitations, but it already includes the multi-image boot and the swap and overwrite only strategies.
I see.
But-
So for someone who's starting new development or trying to support newer MCUs, since the long-term path is to move permanently to MCU boot, I imagine it would make more sense to just stick with MCU boot rather than use TFM fork.
Yes.
Yeah, I
So-
think that would be a good strategy. Right?
Definitely. So if you are a new player, then pick up the upstream MCU boot instead of the fork. It will be deprecated as soon as all the features are upstreamed.
And what differences are there features, whereas I'm trying to understand what I would be missing if I stuck to MCU boot?
The gray box on the right side, this no swap and RAM loading upgrade strategies. Currently, those are in progress. I mean, the upstream is in progress.
I see. So that's in future, but right now, where things are at TFM fork versus MCU boot, what's there in TFM fork that's not there in MCU boot?
The gray boxes. So the no swap and the RAM loading upgrade strategy is a feature which is only available right now in the forked version of MCU boot within TFM.
I see.
But
Okay.
still missing from the upstream, but the
Got it.
upstreaming is in progress.
Okay. And to clarify, by the brief description of no swap, David seemed to indicate that whatever area you download to, it just executes out of there, right?
Yes.
Yeah, yes.
So that would indicate that the download image has to be linked for that address range.
Yes,
Exactly.
exactly.
So that means that it is on the user to link for multiple memory slots depending on where they want it to execute out of.
Yeah, exactly.
Yeah.
But you can find more information on this strategy in in the docs folder, tfm secureboot.rst file, and you can also check this PR 739 on the MCU boot GitHub.
All right, cool. And last question, is there a plan at some point in future for the MCU boot to also support these, or you don't plan to do that? Or you do plan to do it, it says in the future, you will merge it, right?
Sorry, to support what?
Well, the no swap, that's going to be on MCU boot at some point in future?
Yes. I mean, there is already a pull request.
PR right there. Got it.
Yes, to merge this feature. So in a few weeks,
I see. Okay. All right. That's all I had.
I'm
Thank you.
sure it will support no swap and RAM loading after that.
All right. Got it. Thank you.
You're welcome.
Okay. Any other questions, or shall we move to
Hello,
build system?
you can hear me?
Yes, but
Sure.
the
My
voice quality is quite bad.
Yeah.
Maybe could you try it in the chat box?
Okay. But you can't hear it here? Not working well? Okay, I will chat then.
We can hear something, but we cannot
Yeah,
understand.
the sound quality is very poor. It's not recognizable. I propose while you are typing your question, so we can switch to build system, and at the end, David can respond or answer your question.
Yeah, I can answer your question in the chat as well.
Yeah, now it's appeared. Okay, let's go. David, could you answer?
Oh, I lost the chat, but yes, it will remain as part of the TFM.
Mm-hmm. Okay, and
Sorry,
the
Chuck,
build
just
system
one.
and now there's a Reef who are working now on the build system.
Sorry, Anton, can I have one more comment to the previous topic?
Please.
Yeah, so Misha has asked about, so not the full fork will be removed, so only the general part will be removed. Those which are related to TFM, for example, the b2_.main and some platform dependent stuff will stay in TFM and that will be removed. Does it answer your question, Misha?
Yes.
Kind of. Well, I obviously, when we're adopting, trying to use third party or software developed by another group, we want to minimize, how much divergence there is. So whether it's in the form of platform folders or folder structures in general, I was hoping that it would be as close or identical to what's in MCU boot. So we're not missing out anything, but you were saying that there's going to be some differences still?
No, I mean, the main.c is a file which is should be implemented platform specific, and you can treat MCU boot as a library. So that part, which is the generic part, the library, which is do the image authentication, will be the same. But those part which can do some hardware dependent initialization and something like that will be staying in TFM and can be stay in the platform folders in TFM.
I see. Okay. Yeah, I think I understand. Yep. Thank you.
Okay, let's switch to the build system. So we've prepared the presentation, so I want to share this is with all participants. I think it's quite important change, so yeah, Reef, stage is yours.
Oh, hello, can you hear me?
Yeah.
Yes.
Hi, I'm Rafe Coles, and I have been doing a lot of the work on the build system upgrade. So for slides, I actually forgot to put in a slide about why we're upgrading the build system. If you've ever actually looked at it, you will probably understand why. It's very, very large, and it's a lot of calling very generic, strange like macros, and it looks like its own thing. It doesn't look like what other CMakes look like. And for this reason, it's very hard to deal with. It's very hard to extend or modify. So decided that the best option was to effectively rewrite the whole thing using a much more up-to-date CMake paradigm. So the idea of modern CMake is that you have effectively everything is designed as a target. And the way to think about targets is they're somewhat like C++ classes in some ways. So there are lots of ideas of sort of chains of inheritance and things that are bound to targets, so target-specific variables. Whereas previously, a lot of CMake was declare a global variable and just make sure it's not got the same name as anything else, and then just have that propagate globally and have lots of if-defs based on that. So I think these slides are going to be shared somewhere, and there are some links here to modern CMake. I think the one I'd recommend out of these is the cliutils.gitlab.io one. That's probably the best reference, I'd say. But yeah, so everything so currently we have some concept of targets in the CMake, but what's happening is we're basically overriding all the functionality of targets to get roughly the same functionality, but in our own way, which makes it very hard to work with until you've worked out what this sort of layer over the top of targets is. So a target is basically a thing that we're compiling. So almost all of the targets we have in TFM are static libraries. So we'd take a bunch of C files together, and then we'd say that target is a static library. And quite a lot of them are fairly small because the actual cost of compiling things as a static library and then merging two libraries is fairly small. So it means we can get nice separation of different areas of the project, which you'll see later. So one thing to talk about with targets is this idea of the interfaces. So when I was talking about inheritance, for every variable that you have for a target, so the main ones are include directories and compile definitions and compile options. For all of these, you have a scope attached to them, and the scope is either public or private or interface. And the way these works are, if you declare something as public, say a compile option, if something is linked to this target, then it will also use that compile option. And also, the target that you've set this on will also use that compile option. So the way that public works is this target needs this option, and everything that depends on it also needs this option. And then we have private. The private says this target needs this, and the dependents don't need it. And then you have interface, which is a sort of special case one that doesn't turn up very often, is this target doesn't need this, but its dependents do. And you see this quite often in header libraries, is fairly often, because they're a weird special case where they don't actually do any compiling. So header-only libraries tend to have a lot of interface in them. And the nice thing about this is it propagates all the way through dependency chains. So if something is public for a target, and something links to that target, and something links to that other target, then this compile definition will pass all the way down. So quite a lot of the time, you only need to ever define things once. But there are downsides to this, is that if you set everything public, things will get very, very messy. So private definitely should be the default for any settings, and then they should be made public or interface if it is necessary. So there's a nice example for this, which came up today, actually. So it turns out that the CMSE flag should only be turned on in the secure world, because on some platforms, they do some detection based on whether the CMSE flag is enabled. So you can't have it enabled in the non-secure world. So the way that this is done is we have this target compile options on the right, and we say the secure platform has the CMSE flag. And we set that once, we set it public. And this means that everything that is linked to the secure platform suddenly will be compiled with this CMSE flag. And it's only those, so it doesn't affect the non-secure world, and doesn't affect the bootloader. And this propagation is based on this sort of graph that appears of what the dependencies are within our project. But it's very nice that we can just set this in one place, and it automatically propagates everywhere that it's needed. So speaking of a graph, this is currently what the state of the TFM build system is. So all of these nodes are a target, and you can see there are directional arrows, which is this target is linked to this other target. And you can see that, I don't know, can you see my cursor?
Yep.
Yes, so you can see there's the secure platform over there, and this has a lot of things linking to it. So that's how that CMSE flag propagates to all of these, is they're all linked to the secure platform. So the rough overview of what we're doing with targeting the TFM is we have three main top-level targets. They are the bootloader, secure side, and the non-secure side. So secure firmware is effectively TFM. It's got all the secure partitions, it's got the SPM. That's kind of and then that's linked to the secure platform. And then the other two we have, which are they're mostly on their own. There's a couple of links, but they're mainly for the interfaces. So the bootloader sort of exists on its own. It has its own copy of Mbed Crypto. I think it links to the TFM boot status, which possibly the secure world also links to. And then we have the non-secure side, which it also exists on its own, and it links to the PSA interface, which the secure world also links to. And you can sort of see this here, where you've got the PSA API and the PSA interface sort of existing between the two. And then, so we also have some external libraries at the moment. The main ones are Mbed Crypto, and so these are the dependencies you need to download. So we have SimSys and Mbed Crypto, and maybe a third dependency. So one of the nice things that we've done is there's this function in CMake called fetch content, which some people might know as, it used to be external project, where fetch content is the wrapper over external projects. And the upshot of this is what we can do is we can just define a tag and a download location for these dependencies, and CMake will just go and fetch them, which is nice because we've had some issues with dependencies in the past where you do a git pull on TFM and you don't realize that someone's changed a version of a dependency and suddenly something doesn't work. So this way we can link the dependencies quite closely, and we can also make it a lot smoother to start development. It should be just download the repo and you run CMake and it builds. Obviously, this isn't ideal in all circumstances because having to download things every time you have a CMake build is painful on some internet connections. So there is an alternative. You can just set these path variables. So you just set embed crypto path, and this behaves very much like the previous way. So you just point the path variable to where you've installed embed crypto, and it also just works. One of the other big changes is how hardware platform support is done. So as a hardware integrator, you need two files to link to the new CMake. So the two files are a CMake list.txt and a preload.cmake. So the CMake list.txt is effectively just adding files to these targets that exist for each platform. So there's the secure platform, the non-secure platform, and the BL2 platform. And these correspond to the three areas of TFM that I mentioned earlier. So all you do is you work out what parts of your platform support need to be compiled into which target, and then you add those files using, I think it's add target sources. And then you need to set the startup and scatter files for secure, non-secure, and BL2. And then maybe we haven't quite worked out what we're doing with how build options are controlled. So things like, we've got things like builds, Simsys drivers, and things like that. So those, you might also need to set some of those inside the platform to CMake, but that is it, basically. And the platform CMakes have got a lot nicer because they've had a lot of logic removed where it probably didn't make sense to have them in. They've got a lot nicer and a lot smaller. And the other thing that you need is a preload.cmake. And the reason we have this is because of a bit of problems we've had with the way that the CMake toolchains operate, which I will go into in a bit more detail later. But basically what this does is it sets the CPU and it sets the architecture. So they're normally about 3 lines, which says, this is an M33, this is using ARM v8m mainline, and I think the Muscat S1 one also says this is using the CC312 accelerator. And that's all that's in there. So talking of compiler supports, we currently have support for GCC and Clang, and IAR support is in progress. We don't want to break anything, and we don't want to undo all the good work that's been done porting, making TFM work with IAR, and we don't anticipate it being a terrible problem to shift this over to the new build system. So compilers are all in one single CMake toolchain file, which is a somewhat special file. Basically, it's a CMake file that you can set as a special variable, and it will be loaded really first before CMake does anything, and it's used to pick up which compiler you're using and what cross-compilation method you're using. So because we're trying to keep everything in one file, this means that we have occasional variables which are related to the compiler. So things like the CMSE flag is actually the same on GCC and Clang, but it might not necessarily be. So you saw earlier in the example where we set the target compile option with the variable compiler CMSE flag. That's why. So we can keep that all in one place, and we don't have to worry about what compiler don't have to have any if ARM clangs in the actual CMake. And the way that this works as a user is you just set this dcmake toolchain file to toolchain ARM clang, and that's it. Clang is being used. And one thing I will say is, if you look at the current compiler support, I think most compilers are, I think about 20 files for CMake, with some fairly horrible CMake in there. And the new ones, I think both of the new toolchain files are about 100 lines of CMake. And to get a new compiler support, you need to implement, I think, 3 macros, 2 variables, and that's it. And that's all the integration you need. So compiler support has got a lot easier, we think. So what I was talking about earlier with this startup, with this issue with the platform, the preload.cmake. So what happens is CMake will load this toolchain file, but because of a quirk of CMake, the toolchain file won't allow you to access anything that has been defined on the CMake command line. And this is unfortunate because we define the platform on the CMake command line, and the platform depends on which architecture we're using. So we're in a chicken and egg situation where the toolchain file wants to know what architecture we're using, and we can't know that until we've loaded up the platform file, which we can't do in the toolchain file. So the solution to this, and this is somewhat inelegant, but it can be hidden with abstraction, so it's kind of fine. We load up the root CMake lists, and then we immediately load this preload.cmake on the platform. And then we call this compiler reload macro, which is provided by the compiler CMake. And that effectively says, you having set these variables as to what architecture you're using, that just reloads the CMake auto compiler detection so that it picks up the right architecture. So we set some dummy architecture in the toolchain, and then we pick up the real one from preload, and then we reload the compiler. And then we go back to the root CMake lists and pretend we didn't do any of that, and it all just works. So it's not an ideal solution, but it's a fairly neat workaround to this limitation of CMake. So what are the benefits? The benefits are it's a lot smaller. We've removed a lot of code, and the code we've replaced it with is a lot more readable. We've stripped out the platform CMake a lot, so platform porting is now much easier. We have full incremental build support, so if you run make, then it'll probably compile 2 files, as opposed to now when it will quite often do full recompiles on mbed crypto and things like that. And the way we've done this is we've done full CMake integration of mbed crypto, and we also did a rewrite on the CryptoCell accelerator library, so it uses CMake. So all of these things now actually are fully integrated into the CMake. And the other nice thing about this is it's probably possible, we haven't tested this, that because this TFM is now using the CMake, what you might be able to do is just plug CMake TFM into an existing CMake in the same way that we're doing with mbed crypto, where you just say include mbed crypto, and then you can sort of use all the targets it creates. You can probably just include TFM and then just link things to secure firmware and things like that. So what does this mean for changes that you'll have to be aware of? So currently make install is you'll no longer have to run make install to get all the signed binaries and things like that. Those will just be created by make. At the moment, make install tries to install mbed crypto into your computer, which is not good, but that will be disabled by the time we release it. ARM Clang support now requires a newer version of CMake. Previously, we had effectively backported ARM Clang support from CMake 15 into our own project, and this was a lot of complexity that we really shouldn't have been doing because we're a firmware team, we're not a CMake team. So I think the new idea here is if you need ARM Clang support requires CMake 15, just go and get our CMake 15. I don't think the Ubuntu repos have it yet. This will probably be a problem that resolves itself, but an install from source takes about 5 minutes, and it's not too bad. And GCC support doesn't require CMake 15. It will just work with your current version of CMake. And I don't know about IAR, but I think IAR also was on a lower version of CMake, so that should be okay. And we've made some changes to which command line parameters, mainly just naming things. There's a lot of things that were dear going to path just for consistency. So I said that the CMake had got a lot smaller. This is the entire CMake for the Niscure S1 secure platform. And you can see that I can fit it onto one slide, which isn't bad. And B, so here's the scatter and startup files that I mentioned. Here are some include directories. So you say, this is where you can pick up all the headers, and then here are some source files. And that's it. Entire secure platform all on one slide. You can see here we've done some more use of CMake generator expressions. So these are effectively the more modern replacement for the if-else. So instead of if TFL partition platform, then target sources platform S, whatever, we just put this in and it's one line. And this also has some tangential benefits. I believe they can be reevaluated at build time by some CMake generators. So I don't think Make supports this, but maybe the Visual Studio support does. And speaking of generators, we've also tried to keep, so there's been some patches in the mailing list recently about things like Ninja as a build system. So we're going to try and keep everything, all these new features that are being added, we're going to try and keep in the new CMake as well. So this currently has Ninja supports. There's some more patches that are just going in for generating ELF and hex files. We're going to try and get those in as well. So we're trying to make this like definitively better than the old CMake. We shouldn't lose any features. It's not done yet. So our to-do list roughly looks like we need to move the non-secure app to a different repo, which is part of our ongoing restructuring efforts. We need to take a look at the configuration options because there were a lot of them and a lot of them were mutually exclusive and some of them possibly just shouldn't have been exposed. There were lots of things where you could set something and then it would just immediately give you an error because it was completely unsupported by your platform, which isn't great. IAR support is on its way. We need to get hold of an IAR license, but that shouldn't take too long. As I said, compiler porting is quite nice now. We need to do the porting of the tests, but that has there's some other stuff going on with the tests as part of the restructuring. So that will be done at some point, and then we just need to port the remaining platforms, which sounds bad, but as you saw previously, the platform files have got very small. Porting a platform probably takes a couple of days. And that's it. And it does work. I've been building things with it. Currently we support the Musca S1, but it's been working very well and it's very pleasant to use. And that is the end. Any questions?
Hi, Raj.
Okay. Impressive. Please,
Hi,
there are some questions.
Yeah.
Yeah.
Hi, this is
Hi,
Dave.
Rob.
Oh,
Sorry. Please go on. Sorry.
oh, thanks. This is Dave Coca from Renesys. Thanks for the information about this, and I'm just wondering how this connects with the OpenCI project, the Trusted Firmware CI infrastructure project. Is there anyone working on that along with the build environment? So
we will need some tweaks to the CI. Effectively, that slide on how the changes look to you as a user will be needed to be input to the CI. I don't know if we've got someone here who's more connected with the OpenCI project that can talk about that.
Yeah, we have. I think Carl is here, but I think it's quite easy. So I do not see it's quite dependent one to another. So OpenCI is a building environment, a testing environment, but for this building system, it's just another way to build the project. So when we will be ready with this build system, we just switch and adjust OpenCI if necessary, but I don't think it will be necessary.
Yeah, OpenCI will can generate another set of build commands, which will support the new CMake solution.
Okay, and my understanding is there is some work going on already, right, with TFM and the OpenCI project. So, yes, do you have any timeline for how?
Yeah, Anton, do you want me to pick that up?
Yes, please. Yeah.
So you're right, Steve. So OpenCI, there's a phase 2 activity that Linaro infrastructure team is doing. So that is basically trustedfirmware.org contracting Linaro to bring up our OpenCI for TFM and TFA. We had a phase 1 work which completed a few weeks back, which if you go to ci.trustedfirmware.org, you'll see some MPS2 build configurations for TFM and some Juno basic boot test for TFA as well. What we kicked off very recently with Linaro was a phase 2 activity to bring more capability for both TFM and TFA OpenCI. So for TFM, it would be adding more platforms like the ARM FVPR models, Musca A and B boards, static analysis using open, freely available Coverity, having a staging repo to be able to develop more test infrastructure. So the rough timeline is looking like around end of September. And I can possibly post, there's a wiki page in tf.org which lists the Linaro plan, which has got around 11 milestones, which goes until end of September. So if there are members who wants to add boards to this open CI, it's quite possible to work with Linaro to add boards. Either you can wait till September. At that point, I think Linaro plans to produce some documentation giving guidance on how member platforms can be added, or you can, I think, raise it as a pull request to add a specific member platform. I think the prerequisite might be that the platform has to be enabled in Lava, which is the Linaro testing infrastructure. But I can send you a wiki link on chat now, which shows the plan, which goes until around end of September.
Thanks, Shavu.
Yeah, and ARM and all the partners who are interested in TFM is working quite closely with the Linaro infrastructure team. So whatever changes happens in the build system, everything that gets reflected in the OpenCI as well. And I think the repository is quite open, that anyone can push changes, and Linaro acts as maintainers to pull those changes to the infrastructure of the OpenCI.
Good.
Thanks, Shadow. Any questions for the build system?
I have a question. Were other alternatives to this method considered? Because there are others that take care of the SOC dependency, or the device dependencies, board dependencies, tool dependencies, and all, by design. So just curious if those were considered.
Anton, do you want to take this one?
Yeah, please. So you want me to answer, or you?
Oh, yes. Yeah, I think you did more of the investigation to this.
Yeah, all those dependency. I guess you are asking about the build options, not the build system itself.
Yes. Well, asking whether a different build methodology was considered as opposed to this one.
We believe the CMake is first, we do like it. Second, we do have history built on CMake from the beginning, and currently it's a industry de facto standard. I think it's applied and deployed for so many projects. So we're just thinking this is the best way to do it. Yeah.
So I don't know whether it would fit into the schema, but because there is a census build system, basically that takes care of all these dependencies, plus also takes care of the, for an M33 or an M23, how you set the parameters for secure, non-secure on the system. And basically it works with all the different compiler options, the different tools options, many different devices and things like that. So a lot of these dependencies are already solved in a different method. So I was just curious why that, could that work instead of this?
CMC's build system is another way, yeah, true. And maybe it's even could be an attractive, because we are looking for CMCs everywhere. But I think going for this CMC's build, we will narrow down the scope, the application scope of TFM. And in parallel, I think CMC's build system could be exist in parallel to CMake. So I think nothing stops us to do it to use both ways.
Yes, CMake is nice because at its core it is very flexible. You can see by some of the things with the compiler reloading, but because TFM does some fairly strange things, we do need a fairly flexible build system. Things like the secure veneers are an interesting one, because those are a file that's created as a result of compilation that isn't the output file. And getting build systems to recognize files like that turned out to be actually quite tricky, because it's a very weird concept to have. Most build systems will say, well, you compile something and you get a file out, and they're not expecting other files to just sort of appear out of nowhere.
Yeah, I could be wrong, but Simpsys Zone actually takes care of that, or should take care of that.
Okay.
Yeah, so basically answering the question, why not CMCs? It's not the first time we are having this discussion. So I think we want to be as general as possible, applying the most popular tools and most kind of industry conventional tools. So for CMCs, I think we will narrow down this.
Well, except that it can be used in a very generic way, and it is, it is open source, can be extended.
Yeah.
So I guess I just don't see, the way that Simpsys build was conceived and all the different other components from a building perspective lend themselves to solving a lot of these problems by design, as opposed to having to redesign a CMake system to accomplish it. That's my main question. And yeah, you're right. They could exist side by side, but I think you'd have to potentially have to partition the libraries for the different components slightly differently, or make them more componentized so that you could actually pull it together in a cleaner fashion. Which we may want to do anyway, because a lot of components that are inside of TFM could be used outside of TFM too on other systems, and right now they're completely interwoven.
Yeah, true. Yeah, I think could be an interesting follow-up steps is to introduce CMCs built in parallel.
Okay.
Maybe.
Yeah. Hi, Ref.
So just let me add a note to the CMCs related question. So there is another angle, which is TFE is also moving to CMake, and it is an option to have some shared components between the two firmwares and have a consistent user experience between the two build systems. And CMCs is quite well only Cortex-M focused, and we'll lose the potential there. And also CMCs build tools are not mature enough yet. So for example, I don't know how they would work on OS X or BSD or other operating systems, while CMake quite well supports these.
So of course those questions would need to be answered, but that argues for having the different components of the project be basically into individual libraries that could be pulled together in CMake or into a Simpsys build interchangeably. Things like the entity attestation token, storage, all those different things. I agree, you're going to need components of those for both environments, but by nature of how Cortex-M platforms are or microcontroller code is done, it's having the benefit of having the tools have the capability to do work for you, as opposed to having to build it into your actual make system, has a lot of advantages for end developers and product developers, not necessarily the systems developers that are doing the baseline components.
Yeah. Thank you. Any other question?
Yeah, I have one. Hi, Ref. Thank you for the share. That it looks like in good shape. I have two questions about some details. First one about the step sequence. So actually, in special case of dual core system, secure and non-secure side may have different configurations, like CPU architecture and platform-specific configuration. So it seems like it only reads once from the preloads.cmake. So can this stop sequence cover the different configuration scenarios of dual core system?
So what because the preload does the full compiler reload, I think it's hard to say because I'm not sure how clever CMake is. Certainly because so you can certainly run the preload.cmake again, or a second file which contained a different set of architectures and also this compiler reload function. And that would effectively switch the compiler over to a different core. I'm not entirely clear on if you did, say, ran this preload, then compiled the non-secure, and then ran the second preload, then compiled the secure. I'm not entirely clear what CMake would do about that. I think
to answer.
Yeah, that's a bit tough. We need to look into the dual core support is also something I've actually forgot to put on the to-do list, but it's also on the to-do list. In theory, as I said, because these targets have different compile options, there isn't actually, in theory, we can have different compile options for secure and non-secure. How we set that up might be a little bit tricky, but I think in principle, you should be able to do it fairly elegantly.
I have a question. I have an answer for this. And thanks to this new way how we support this tool chain. So previously we tried to kind of unify any use case and put all platforms to cover by the same set of CMake files. Now you have a toolchain file. So if dual core is a special case, which is a really special case, thanks to this dual core, we have too many if-else in the compiler support. So instead of this, we can implement toolchain dual core something and put the special logic for dual chain. So it will be clear and elegantly separated from the rest of it.
I think it can be more easier if we can put preload setting, into the secure firmware and the application respectively. So, in secure firmware and application, it will do the reloads actually twice to get different configurations. So we don't need a very special, very high level special sequence for dual core and for single core.
Yes, that ought to work actually, because CMake will also have a separate set of compile options when it descends the directory tree, if that makes sense. So we can have a separate set of compile options for anything in the secure firmware folder. So we could, in theory, just run compiler reload. We could, in theory, just run these preloads every time we got into a folder. If, say, you would set up the TFM secure preload, we could just effectively run that, and then that would set up the compiler options. So that should work.
Yep. Another question. Yeah, there are actually multiples of configuration prefix with build underscore, for example, build underscore flash. So these flags are on and off in every module. For example, when we build secure firmware, we put build flash flag on to include some flash operation in ITS and protected storage. And in other, when we build other module, we have to clear this flag again. So is there any solution to to make those flags more more to simplify them?
Yes. So if you need, so what you could do is you could set up effectively a target that was an interface target. And the thing about interface targets is they don't actually have to have any files attached. So you could literally have this interface target that only depends on this, that basically says this is a flash, that like has the flash option in it. And then you could just link all of these things to the flash option. And then that would just pull that out into all of the separate targets. Separately, I think you can undefine things, I believe. And again, options can be separate for a file or a target. So you could take a target that didn't need this flash define, and you could just define it away, and that would be okay. Is there another way?
Yeah, because it's quite complex, because these flags are set in every module, but actually they are used in platform specific files. So in platform files, CMake, it will check if this flag is on or off, then it includes different files or do something according to the flags. So
hang on.
Yeah, so it actually also depends on the start sequence. It's a lot of, circle dependency.
Yes, so CMake is actually very good at handling circular dependencies in this case, because we're building everything as a static library. It tends to just sort of it actually does quite well with sort of very circular dependencies. So I think we're still looking into how options propagate throughout TFM is still sort of an open question, and we're still working on that. But in general, if you wanted a setting that said this needs to have the flash driver on, then what I would do is I would have a CMake variable that had basically whether you want this flash driver on or off. And then you can do things like these generator expressions, which allow you to specify which files need to be built. So these are all Booleans, but you can do string equals and things. So you could say, if the flash driver is on, add this file, else add this file. And then inside particular targets, you can do things like, hang on, I have one somewhere around here. You can do something like these target compile options, and you can also put in a generator expression. So you can basically set, because the compile options are the C defines. So if you want some flash macro defined, then you could just put it in here with a generator expression, and then that would either be on or off depending on this CMake variable. And then you could just do that privately for the files, and then that way you can have this very specific, it only affects some files and it doesn't go everywhere like it would if it was public, where it sort of spreads throughout the whole project.
Excuse me, I have to remind that we are running out of time. And maybe
yes,
somebody has another plan. I want to remind that we have mailing list. Please ask questions in the mailing list. Do not hesitate. So let's continue the discussion there.
Maybe one last question. This is going to be a quick one, Anton. Have you informed IAR about this? They might have some changes to upstream once this gets merged.
Inform whom?
IAR.
Yeah, yeah. We already requested licenses, and we got the licenses, so we have it.
Okay, so this is all verified already with IAR then?
Not verified yet. It's in the process, but yeah, we do remember about IAR.
Yeah. Okay.
I also see Thomas from IAR is on the call, I believe.
Yeah. Well, and one more related thing is we do create it. Changes is quite big, and it also connected with the code restructuring, what is going on in parallel, and it should be linked and synchronized together. And testing and CI, and because of those big changes, we do introduce a feature branch. At the moment, it's empty, but very soon we might find this new build system in a feature branch named Feature UX Build System. I think something like that. in the our repository. That's all. I see some chat and maybe some questions.
Just one question. Are we intending to use the CMake variable tree as the kind of begin all end all for states propagated between the different components, or have kconfig or similar?
We are thinking about kconfig.
Okay.
Yeah, this is still up in the air. It's this. So at the moment we've got this nice infrastructure of if we can have CMake variables defined, then we can get all these compile options sorted out. But how we're setting up the CMake variables is still sort of an open question.
Yeah, from the Zephyr project, we have married the kind of kconfig and the CMake variables, meaning every kconfig variable automatically propagates into a CMake variable.
Yeah, that's our direction as well.
Yeah. So, and the other thing I wanted to ask about: have you used any of these symbol tree to generate any kind of header files with defined sets using, for instance, CMake define macro inside CMake, or are you just keeping the state in CMake as variables?
I think we're trying to keep the state in CMake as much as possible. There are a couple that have, I think, MCU boot has this done.
Yes, it uses it.
Yeah, so I think in general we have lent towards keeping the state in CMake, as it, because that was how it previously was. I think we've not done so much of the CMake keeping state in the build system, in the files.
So I think this question also relates to refactoring, because historically TFM code was not written to use configuration headers.
Right. Thanks, Georgian. Then let's close this meeting. Yeah, we are already 5 minutes over. Thank you, everyone. Please ask your questions over the mailing list, and you will see the recording session and the presentation file in the trustedfirmware.org website. Have a good day. Bye.
Thank you.
Thanks.
Thank you. Bye.
Thanks. Bye.